Hello grade 10, so this is the second part of our compound fractions lesson. Here we're going to look at continued fractions, but before we get there we're going to just revise quadratic equations which you learned in core maths, but we need it in this lesson. You will spend more time revising this later on. So we are looking at a quadratic equations, which means generally the instructions will be solve for x, and you will get something along a question along these lines. When you look at this equation, what should stand out to you is the x squared, and that's how to identify that it is a quadratic equation. From there, you're going to do the following 3 steps. Step number 1, you're going to make the equation equal to 0. Now, luckily for us, this equation is already equal to 0. The second step is you're going to factorize. And so we look at this, it is a trinomial. So we're going to have to use 2 brackets. And we know x times x gives me x squared. And a positive times a negative gives me a negative. So we know we're subtracting. And our options for 4 is 1 times 4 or 2 times 2. Now, we know that 2 minus 2 is not going to give us 3 because the signs are different. But 4 minus 1 will give me 3. So the factors is 4 and 1. And then positive 4 minus negative 1 will give me a positive 3. And there are my factors. The third step is your OR, where you're going to take it and you're going to say, well, if this times this is equal to 0, one of these binomials should be equal to 0. So either x plus 4 is equal to 0 or x minus 1 is equal to 0. And then you solve for x like you did in grade 8. So you're going to subtract 4 from each side, which gives you x is equal to negative 4. And in this one, you will add 1 to both sides. And so x is equal to 1. If you really want to, you can skip this step and look at your brackets individually as to what x needs to be to make that brackets 0. Let's try one more example before we continue with our video on compound fractions. So here we have 5x minus 6 is equal to x squared. So immediately you see the x squared and you know that step 1 is equal to 0. Now, the best way forward is you want a positive x squared. It's easiest to factorize that way. So I'm going to subtract 5x and add 6 to give me 0. And what I do to the one side, I do to the other side. So I'm going to have minus 5x and I'm going to add 6. Second step is going to be factorize. And so we got a trinomial once again. So I know I'm going to have 2 brackets. Only x times x will give me x squared. For 6, it's a positive. So I'm going to either multiply a negative with a negative or a positive and a positive. And so I look at my sign in the middle here. And only 2 negatives will give me a negative added or subtracted. So we know that we're adding to get to 5. And so my only factors of 6 added will give 2 and 3 to give me 5. And so I say to myself, the last step is going to be my OR. And so you can skip the step where you make each bracket equal to 0 and you can go straight and look inside here. What minus 2, or you can have the equation x minus 2 is equal to 0 in your mind, and that'll give you x is equal to 2 for the first bracket. And don't forget your OR. My other option is x is equal to 3. 3 minus 3 is equal to 0. Now that we have revised quadratic equations, we can continue to our continued fractions. this is where your actual notes are going to start. Before we can look at our continued fractions, there's something you need to remember from grade 8. If I have 1 divided by this fraction, it would be the same as saying 1 divided by 3 over 2. And if you wanted to simplify it in grade 8, you would have tips and times, which would have been 1 times 2 over 3, which would have given you the answer of 2 over 3. Now, what I want to point out is that we can also work backwards on this concept. So if I have 2 over 3, another way to write it is 1 over, and I flip over my fraction. Right, let's get into our first part of continued fractions. The first part of continued fractions we're going to look at is how to create them, which will give you an understanding of how we get these continued fractions. So, create a continued fraction using, and here we've got our first question that we're going to use. Now I'm using big numbers, but that's because it will give us a nice looking continued fraction and not a very limpy, pathetic one. So you might need to use your calculator to help you with some of the calculations, and let's start. So the first thing we will do is, if you look at this fraction, you can see that it is an improper fraction. So if we say 43 divided by 19, we get 2 and remainder 5 over 19. Now we're going to use our concept that we learned at the beginning, so we can take this fraction further and say 2 plus, and I want to tip that over so that it becomes an improper fraction again. To do that, I need to put 1 over the fraction, so I'm going to have 1 over 19 over 5. Now that I've got an improper fraction again, I can divide 5 into 19 and get a whole number, which we want. So we're going to have 2 plus 1 over 19 divided by 5 is 3 plus 4 over 5. Once again, you can see 4 over 5, if we tip it over, we'll get another improper fraction. And so we can take this fraction further. And so 2 plus 1 over 3 plus, and I put 1 at the top, and I tip over my fraction, which gives me 5 over 4. And so we can take that, simplify that fraction, improper fraction further, and that will be 2 plus 5 divided by 4 is 1 plus 1 over 4. And now, if we look at this one, we could tip 4 over 1 and get an improper fraction. But 4 divided by 1 will just leave me with 4, which will bring me back to 1/4. And so we will stop at this point. And as you can see, we've got a continued fraction, a fraction in a fraction in a fraction. Let's look at our second example. Here you will definitely need your calculator. So on your calculator, 225 divided by 157 will give you 1. Now you need to work out the remainder. So 225 minus 157 should give you 68, and that will be over 157. So can we continue this fraction? What do you think we need to do next to continue the fraction? You are correct. We're going to keep the 1, and we're going to put 1 over our fraction so that we can tip it over and have 157 instead, divided by 68, in which case we can divide into 157 and get a mixed number. Using your calculator, I would take 157 divided by 68, and that will give you 2 plus. And if you use your SD button, Shift SD, it will give you the fraction in a mixed number form, and so you don't need to do anything to work out your remainder. It will give you 2 and 21 over 68. Can we continue this fraction further? Of course. If we flip over 68 over 21, we can see we will get another improper fraction. So let's continue further. 1 plus and you put 68 over 21 into your calculator, push equals, Shift SD, and that will give you the following. It should give you 3 plus 5 over 21. And so we can take this one another step further. So I put 1 over 5 over 21, so that will be 21 over 5. And put 21 over 5 into your calculator to find the next step of your continued fraction. Right, we've put 1 over 21 over 5 to flip over 5 over 21. And you put 21 over 5 into your calculator, and your mixed number should be 4 and 1/5. Can we continue this continued fraction any further? Hopefully your answer was no, because if we flip over 1 over 5, it will give us 5 over 1, which will just simply bring us back to 1 over 5. And so this is the end of this continued fraction. Not all continued fractions end like these. Some fractions continue going on and on forever. And we will look at this in the next question. Moving on to our next type of question. Here you can see we have a continued fraction, but instead of ending, it has this ... at the end, which means that it continues like this forever and ever. Now, if you look carefully at the pattern, we've got 7 plus 18 over 7 plus 18 over, and so we're always adding 7 to the new fraction, 7 plus ... and it continues on in this pattern forever and ever. And so a question like this will ask you to calculate the value of this continued fraction. Now you might think that it is impossible because it is carrying on forever and ever, but the fact that it's carrying on and on forever in the same pattern helps us to solve the value of this calculation. So what I want you to understand is what we do is if I take this fraction and I make it equal to x, right? If I take this little part underneath that fraction line and I bring it down over here, I can make this also be equal to x. Because it continues on and on, I can add an 18 over 7 plus ... And if you look at this, it is exactly the same as that, which means that if this is equal to x, the stuff underneath that fraction line we can replace with x. So instead of this, we will replace that with x. And if you look at that equation, it looks a whole lot more simpler to answer. And so let's bring that down. So 7 plus 18 over x is equal to x. Now we've got an x as our LCD in our equation. So our LCD is equal to x. So we need to multiply everything else by x to have the same LCD so that we don't need an LCD anymore. So 7x plus 18 is equal to x squared. And notice we've got an x squared, which means we are doing quadratics. So we want this to be equal to 0. 0 is equal to x squared minus 7x minus 18. Step number 2, we are going to factorize. So 0 is equal to 2 brackets because it's a trinomial. We're going to have an x and an x. We know our signs are going to be different so that we can get a negative in front of our 18. And we're going to subtract. So my factors of 18 that subtract to give me 7 will be 9 and 2. And to get negative 7, the 9 must be negative and the 2 must be positive. Now we go for our OR. So what minus 9 gives me 0? X must be equal to 9. Or what plus 2 will give us 0, and so x must be equal to negative 2. And so we've got 2 possible answers. But when you look at your calculation over here, 7 plus a fraction plus another fraction plus another fraction, do you think that we can get a negative value from adding positive numbers? No. And so because it's a negative, we don't consider that. And so we only have one possible x value. And so the value of this continuous fraction is 9. Here is another example of continued fractions and calculating the value of it. So here you can see our new pattern, 1 plus 20 over 1 plus 20 over 1 plus, and it continues on and on forever. So your first step will be to make it equal to x. Your second step will be to start rewriting the fraction. So it's going to be 1 plus 20 over 1. Wait, I've already got my 1. And that's when you know you need to put your x, because now you are going back to the start of your pattern. And so that will be equal to x. Once again, your LCD is equal to x. And so you're going to go through and multiply every term by x to get rid of your denominator. And so you're going to have x plus 20 is equal to x squared. You immediately see the x squared and you know you're doing a quadratic equation. And so you make your equation equal to 0, preferably keeping your x squared positive, making it easier to factorize. Now that we've got it equal to 0, we're going to factorize. And once again, we have a trinomial, so we have 2 brackets. Only x times x gives me x squared. We can see we're going to have different signs. And I say what times what gives me 20, but subtracted gives me 1, and that would be 4 and 5. And then to get my signs, we know the bigger number must be negative because the middle term is negative. And so the last step is our OR. So x must be equal to -4 to make x plus 4 0, or x must be equal to 5 to make x minus 5 equal to 0. And now we look at our answers here, and we say, look at our fraction. Is that going to be a positive or negative fraction? It's a positive fraction, so we can only go with the positive answer. So x is equal to 5. Once again, grade 10s, remember if you have any questions, make a note of them, and we will make sure to take some time in one of our AP lessons to answer any questions that you may have, or else you may come and find me, Miss Loveland, and personally ask me those questions. I am in room 130, and I'm always happy to help. Before I go, once again, you need to practice these. So you're going to go to exercise 1.7 on page 10, and you're going to complete the exercise doing number 2 to 5. Number 4 and 5 are complex questions to give you a good challenge for those problem-solving questions. Thank you for taking your time to listen to me, grade 10s, and hopefully we'll see you soon.